So I had hoped to release between last time and this time some exercise. I'm leaving them for after today because I was just overloaded with some firefighting and so on. But today we're going to build on some of our learning from the last session, both in using joins to link together tables within Cassandra, and specifically within the Ethica databases stored within Cassandra, storing GPS, accelerometry, and individual self-response information. We are further going to make additional use of the visualizations we saw in Zeppelin, which you'll recall allow us to nimbly take data which we've extracted from databases and project them into visualizations spaces in ways that are quite interactive in Zeppelin. So I'm going to switch over to the screen sharing mode here. If anyone wants to join, I'll do present to everyone. Here we go. And just to remind people of what happened during our last lecture, we had gone through a set of examples where we had connected in with Cassandra, extracted some information. We had defined some filtering on that. We had defined a user-defined function, which where this UDF invocation here, this lifts a function from operating on particular values, in this case timestamps, to operating instead on columns of those things, columns of timestamps. And we added new columns that consisted of the UDF applied to the old columns, so columns that consisted of kind of process data from earlier. We had selected subsets of data using select, and so doing this, we had eventually gotten to the point where we joined together two data sets. These data sets were joined based on shared attributes between those data sets, namely the user and the time slot. We used time slot rather than time because we weren't guaranteed to have measurements of the two things being joined at precisely the same time. GPS data only comes in episodically, perhaps every minute or two or something like that. And we can't be sure that GPS data datum is received at the same time that someone happens to answer a survey. They may be at different seconds, right? And even something like accelerometry data, it may not be guaranteed that it's exactly the same time. So because of that, we had binned the data into slots, time slots, which were 10 minutes each. And that's what we did with one of the UDFs. We had defined time slots to sort of bin the data according to this criteria defined by the UDF, which indicated 10-minute bins. Okay, these are going to be recurrent patterns we're going to see again and again. UDFs, adding new columns which capture information, selecting out of columns, filtering elements, and performing joins. Those are going to be par for the course for a lot of our work here. Having performed those joins, which were a very labor-intensive operation for the computer, took your computer sometimes, we were then able to do some further extraction of information from them, etc. And one of the types of information that one of the types of investigations we performed using that data was extraction of it and placement of it into temporary databases. That's this temp view, which then allowed us to issue these SQL-like queries, which could then be visualized in any number of different ways within the context of Zeppelin. Okay, to be clear here, most of the operations here we're doing are pure Spark. Spark, of course, working with Cassandra. But these operations are ones that take unique advantage of the Zeppelin context in displaying things. Okay. So that's what we did, and as I noted, I'll have some additional exercise I think I'll ask you to do over the weekend. But this provided us a very flexible way of displaying this sort of data extracted from Zeppelin, and sometimes the data was displayed in more raw form. Often we processed the data into categories like bins, which kind of clumped speeds between 10 and 15 kilometers per hour and 15 and 20 kilometers per hour or something like that into broad bins. In other cases, we graphed out more raw data. Okay, we'll have further to go with that, but today we're going to be tapping into something we only really just barely got into last time, in the last two times. Specifically, you may remember that we actually did extract survey response data. Do you remember that? So we extracted from one of the tables in Cassandra, in the Cassandra database, one of the Ethica tables, we extracted survey response information. And the schema for it was rather involved. Okay, so it involved information about the survey ID associated, et cetera. I think these days, if I'm not mistaken, Ethica has just recently incorporated survey version information. This is very important for those working with Ethica because if you're modifying surveys over time, maybe you correct a typo or change one of the answer possibilities, you want to know for a given response which version of the survey was it using. And as some of you know, with Ethica, it's not, you may publish a new version of the survey, but it could be that by the time that someone answers the questions after that, but they're answering them at a time their phone hasn't yet gotten the new version of the survey. It's still operating with an old version because it hasn't gone online yet or whatever. And so this whole idea of sort of knowing what versions of the survey were used to elicit certain responses is actually pretty important. I mean, Mohammed made some reference to that recently, the chief developer there. Okay. In addition to that, though, and this is going to, well, last time we focused on this duration, which was an encoding of values that indicated how, if at all, and in what context or how long required for the user to answer the surveys, okay? And it had a set of different values, and we had a UDF which clumped them into different groups. So here, if it was -2, it was considered canceled. If it were -1, it was considered expired. This is a code system. This is a coding sort of convention used in Ethica. And if it's 0 or more, it's answered in that many minutes, okay? So we use this and we sort of classified it into a duration category, not just having durations, but a duration category, which was a string returned by this, okay? And we're going to use that quite a bit today. We are going to further be delving into this, which is really our foremost query today. This, ladies and gentlemen, are the responses on the survey, okay? How people responded to the survey, okay? The reason we haven't gone into that is because it's a fairly involved type of structure. And particularly, this string is going to be a JSON string, okay? JavaScript object notation. And it's going to be structured in quite complex ways. And we need a principled way of extracting that information. This can be extremely important because maybe we want to know not just where people were when they answered any old survey of a certain type, but where they were when they answered a certain way on that survey, right? So they said that they, felt limited enthusiasm about their service dog or something like that, right? Or they felt sick to their stomach or something like that for the foodborne illness study. So Ethica provides a way of kind of graphing out where people, engaged with surveys, but not where they answered certain things. So this is going to be our query today. Is a lot of it is about this RESPs, okay? And the RESPs are going to allow us to know for a given question how people answered. Sometimes it may be one answer. Sometimes it may be many alternative answers. Like they say, they have a set of checkboxes. They can choose several different ones of them, right? Okay. Anyway, that's where we're going today. But just remind you that we're building on some background that we learned about last time. Okay. So I'm going to create a new note. Today is going to be February, oops, not February anymore, March 8th. And this is going to be extracting Ethica, Ethica survey answers from Cassandra, right? From in Spark. Okay. Extracting and analyzing. There we go. Okay, now critically, and this was what I didn't do last time, should have paid attention. Let's pick Spark Cassandra as the default interpreter, right? Why? Because that allows us to know how to connect to Cassandra. It allows us to import the requisite libraries for connecting with Cassandra, okay? Okay, here we go. Okay, so ladies and gentlemen, the first thing I'd like you to do, so make sure if you forgot to do that, if you forgot to say Cassandra, what you can do is go to the, oh, not this one, interpreter binding. Make sure this is at the top and it says default there, right? If it isn't, you drag it up there and you don't click so that it's white. You keep it blue, right? Yeah, okay, great. Okay, so the first thing that we're going to do is something that we used to do manually for Cassandra context, which is to load the libraries in, okay? Load a library. We're going to need a library for working with JSON, okay? And we need to load this library before we get going with the interpreter, okay? We don't want to start doing Spark commands before we've loaded this library, because the way it works in Zeppelin is that the libraries like this have to be declared before you're starting the interpreter, okay? Before you actually start processing with it. So we'll load them in and get them all squirreled away before we start actually doing work. So what we're going to do is we're going to do spark-cassandra.dep, okay? This is whatever your name of that interpreter is that you're using. So if you have Spark Cassandra with a capital S, that's what you'd want. Otherwise, I think lower S. Winchell made an underits at one point that it doesn't matter much, but I haven't verified that personally. But as normal, I think Winchell is probably correct. Lift dash JSON underbar 2.6.2. Okay. So I will put this up on a big screen if you'd, oops. Oh, there we are. If you'd like, would you like me to put it up on a bigger screen so you could see it? Tell me, can you see it through the YouTube, or is it unreadable? It is readable? Okay. Here, I can do this. Boom. And I think, there we go. What do you think of that? Is that readable? Okay. Okay, so what are we doing here? What are we doing by loading this in? Well, first of all, what is this thing? Can anyone tell me? What does that look like to you? Please don't tell me gibberish. What does that look like? It turns out it's a Maven. It's a Maven string that we use to specify to Maven, the Maven sort of dependency management system. what to download, okay? So we're downloading a certain library. It's this version. It's for Java 2.11, and the organization associated with it, organization or package associated with it is net.liftweb, okay? So Lift is a extremely powerful web-based Scala environment, Scala Lift, okay? And it actually confusedly competes with Scala Play. But that's neither here nor there. The point is, this is going to provide us, this library provides us a way of manipulating JSON objects, okay? Parsing them and rendering them into Scala objects. And that's what we need, okay? Anyone need more time for this? Okay, so having done that, this dep is indicating dependencies up front. I'm going to execute. And what's probably going to happen is that it's going to take a little bit of time. This is for two reasons, as best I understand it. Reason one, it's actually starting the interpreter itself, the Spark associated with Spark Cassandra. The second thing is I think it's loading this in from the Maven repositories. Maven repositories have a unbelievably large set of libraries on them. For those not familiar with it, if I were to search online here, what I'd find is that the Maven repository, you know, a whole set of information on this library, et cetera, who produced it, et cetera. Different versions of it that I could get in different ways of loading it in. And it's actually going to go load it in as a JSON file. Oh, sorry, as a jar file. Okay. So the key thing is to do this before starting the Spark interpreter. If you do it after starting the Spark interpreter, it'll say you have to go restart it, and you'd have to go up here and do this little thing. And Winchell actually says it's better to go to all interpreters and do it there. And you don't want to do that. Just you want to do it up front. Okay, that's why we're loading this up front, even though we're not going to need it absolutely immediately. Are you okay with that? Okay. So this gets the library ready for our later loading. First, though, before we actually futz with that, we want to load our general library for the Cassandra connector, so we can get things out of Cassandra. Okay, I'm going to load this in. Now, this was the guide. Does anyone remember? How does it know how to load this? Because that's the library associated with the Spark Cassandra interpreter that we created before. Okay, it told it how to load the requisite library. Okay, so it should then load that. Okay, next, what we're going to do next is actually going to build very directly on what we did last time. Okay, and if you have what we did last time, I would actually suggest going there and copying and putting it in here just so you don't make mistakes. It's actually where we extracted information on survey responses, okay? So we had a survey response thing. Do you remember this? Survey responses, we extracted them last time like this. If you want to load those in, that would prevent you from having to do it again now. I'm going to go copy those into mine, okay? I'll go copy them for those looking at my screen here. Here we are, boom. So I'm going to copy those into my area here. It's basically a very routine thing, and really we should create a method to handle this so we don't have to do it in such a wordy way. Really, we should only have to type the table name, and it should be able to, table name and probably the study name. But this is what we're doing. So we are going to Cassandra. Oh, sorry. We're saying, okay, we're going to get data from a Cassandra database. We're saying the key space is this key space, and the table is this table of survey responses. Are we okay with that? Okay. Okay, next. Let's go check them out. let's go check out the schema, right? Make sure we're all cooking with gas. Boom. By the way, what is this thing? Why are there these little arrows here? What's going on here? This is begins with an M and ends with a P. It's an A in the middle. A map, yeah. It's not Pam. Okay. So here are the survey responses, and there we have that structure. Do you see that? Okay, great. So the next thing we're going to do is just put in place the same mechanisms we did last time with for grouping these into time slots. So once again, and I would have asked you to copy it over at the same time, except I don't think there's an easy way to do this in Zeppelin. If you go to last times, here we go, and there's this UDF for time slot from timestamp. Remember that? We did 10 minutes. Remember this? Time slot from timestamp. We're going to copy that guy over as well.
You have multiple.
This is true. The only problem is that when we created Spark Cassandra, I gave an instruction to have it isolated per notebook, okay, which means it wouldn't actually know about the definitions and other things by default.
So you can switch back and forth and copy paste slightly more easily.
Oh, good call. Okay, yeah. Thank you, Wade. That's actually much simpler idea. Okay, I see what you're saying. So what Wade was saying, I finally got it through my head, is he was saying basically we could have this open in one tab, and we could have another tab open with, and I'm going to have to see how to. I think I'll go boom, put this over here. And then I could do with another tab where I go back to today's lecture, right? Here we go, boom. And then I could just switch tabs instead of switching over manually. Okay, so gonna wait a minute. This is okay. Problem is my screen area is so limited that I can't even read the full name. This is last times. Yeah, this is last times. So for this time, we want the March 8th one. And this is it. Yeah. Okay. Sorry. There we go. Okay. So let's just, oh, that's not what I want either. Okay. It was up here. Here we go. Boom. And that's use the GPS table. It's sorry, it's the yeah, that's true. We also, so we applied it to GPS, but we also applied it, it turns out, last time to the survey responses. This is where we loaded the survey responses in. And we then, later, I guess it was after this, we went and there, here it is. We applied it to survey responses too. Yeah. So that's the virtue of these UDFs, these user-defined functions, that we can apply them. We can apply them generically for many different things. So later we went back and we time slotted the survey responses so we can match the two up. And in fact, Yuan, it's a great question, but that formed the basis for cross-linking the two with this join. See here, we joined it on the time slots. So that required us to apply it to both. Okay. Thank you. Okay. So, but since Yuan is talking about it, we might as well just apply it right now to the time slotted survey responses. So let's go do that. So I'm copying, last time we added a thing called time slot to the survey responses based on the record time. And I'm going to copy that also over to here. Okay. And let's go perform that. Okay, it's mumble. So we need to actually do it. It's not called PA. It's called, oh, it's not Moose Jaw. It's PA stands for physical activity here. Okay, it's called DF survey responses. So I just added a new column called time slot, which contains the contents of applying this user-defined function, which classifies the record time into 10-minute categories. Are we okay with that? Okay. So now this DF time-slotted survey response, in contrast to what we saw earlier, if I were to do print schema on this new thing, what would I see? Yeah, if I did print schema, I would see this new column, which is a string column. Which is a long column. Yeah, which classifies it. Okay, into bins. Okay, so we're cooking with gas. So now what I'd like to do is I'd like to create a restricted version of that. Is there any reason we have to do it with a restrictive version? No, I think we'll skip that part. Okay, so now what I'd like to do, we've set things up. We've gotten things ready, okay? Oh, yeah, actually, there is one restriction I want to put into place. I want to be operating off of data from one survey, not multiple surveys. Well, I can have multiple people, right? So we don't bore you. But we need one survey because we want question 1 to be the same for all the question responses. We want question 2. If it's different surveys, question 2 will be totally different things. We got that? Okay, so I would like to put into place val df PA sampling survey responses. Okay, it's going to be this one we just defined, time slotted survey responses. Dot. Maybe we could close the door there so I don't. So so we don't trouble people in the lab. We want to limit the trouble to people in here. Okay, and what we're going to do is we're going to restrict it to survey underbar ID triple equals 242. Okay, 242. Okay, so I'm sorry, I know it's truncated in a most unfortunate way by that. I'll just move it down here. Okay, so we're limiting the responses to what we have through survey 242. So we're all operating off of the same same one. Okay. Okay. Great. Okay, we're going to now execute that. So here we're going to be dealing with survey responses specifically from there. Now, you notice all of this has been going on whip fast, which is probably an indication that it's Spark being lazy, that it's not yet occurring. Let's go ask how many such survey responses there are, shall we? Here we go. Okay. And now the actual work is going to be done. It's going to load in data and so on. And it's somewhere upwards of 1,700, just short of 1,800. Okay. Okay, we're dealing with some data here. Okay, now we want to delve into it, right? Well, let's warm it up a little bit, right? Let's warm up a little bit. I want to create a graph of how long it took for people to answer these things, or how many were in each bin. Well, okay, well, we'll leave that. We did that last time. There'll be exercises. Okay, so let's go import net.liftweb.json under bar 1. Okay. And we are going to do this. Okay, so this lift web JSON, dot here. Where is that coming from? How does it know how to load this in? What do you think? So yeah, it was this that we told it up here. So it's loaded the library here, like it actually went and got the jar file and brought it down and has it resident. Now, it's notable that if this is running on a farm of machines, what this is doing is every one of those machines is downloading it, okay? So it's actually, they're all downloading this JSON file so that they can access it. And now what we're doing is we're actually loading in so we can manipulate it. It's in our namespace, et cetera, okay? And then we're using what are called Scala implicits to just simplify our life here. Basically, these default formats will allow us to have it automatically sort of use some information about how to handle, I think, JSON formats or something, so we don't have to specify it in a wordy way. I'd have to investigate exactly where these come in. But basically, Scala implicits are commonly used to allow complex operations that have the option of having some information provided to them, additionally, to make them very precise. If you don't want to do that, if you want to use them in a far less wordy, simple way, you just use these implicits, and they contextually provide the information it needs to do its job without you having to explicitly specify it, okay? This is done in a quite nice, functional way, but it's but it can seem like a bit of magic until you get into it, okay? So these default formats deal with the defaults of JSON. An example of this might be string encodings, UTF, 1099 or whatever it is. Or these are sort of different types of encodings for strings, and maybe you just want to deal with standard ones. Okay, next. Now we're going to do something we have not done recently. We've not done since introducing Spark, but it's going to be very important for dealing with extracting survey responses, okay? We are going to define, of all things, a case class. And in fact, not just one case class, but multiple case classes. Why? Why define a case class?
Do we have a typed data set?
Yeah, we have a typed data set, which we're going to be using to manipulate the results of responses on the surveys. Now, I kind of feel obliged to show you why we're doing this by giving you a glimpse of the madness that lies before us if we don't do this, if we don't parse JSON, et cetera, okay? So what I'm going to do, and this is going to be ad-libbed here, but I'm going to go look at some of the data in this map. This is a map from question number to responses to that question, okay? I'd like to look at the variety of types of information here that that are in that JSON file. Now, it struck me that before I do this, probably what we should do is restrict it to cases where the person actually answered the survey. How would we do that? Suppose I wanted to do that with this PA sampling survey responses. Suppose I want to restrict this not to all questions, all surveys that expired, et cetera, but ones that actually got answered. How would I do this? Yeah, filter by what? I should have anticipated this earlier, but by begins with D, ends with an N. There's an R in the middle. Duration. Yeah. Okay. Duration greater than or equal to 0. Okay. Now we've got to make sure that doesn't cause problems, but it looks like a happy camper. Let's see how many of those there were where it was actually answered. 376. Okay. 376 of them. Okay. So now, having counted them, let's go view some of them, shall we not? View or not? View. Yeah, indeed. Okay, so let's go see some of these resps, right? Okay. So suppose I wanted to go view the responses. They're in a field called resps. What would be one way to do this? I could do show here, right? Take a look at show, right? And I'll see a lot of things, but it's kind of cramped, right? You're starting to peek out at them there. But I could do select, right? What would I select? Resps. I could show just the resps here, right? Oops, shows, show. Boom. There we are. Okay, do you see them? Okay. And I could go, and I'm doing this from memory. I think, yes, collect. There we are. Do you see what I got out of collect? This is a point of great interest for us. What did I get out of collect? Yes, I got a collection out that collected together these responses. And I extracted into, in short, a sculpture, namely an array. And note there's a map. Do you see that? So let's go collect this array. Val array responses. Here we go. You ready? You might think you're all home free now. What is it? Oh, mumble. Of course. It's Scala, not language. Okay, there we go. This is a map, right? What do I do with a map? What can I do with a map? If I have a map, what can I do? Oh, this is a map. So, sorry? Yeah, and actually, it's even more messy than that because this is a row, and the row contains a map, and I could do a flat map, yeah. As it turns out, we'd have to extract it from the row, and I don't want to actually get into this in too much detail, but you could see the JSON structure here, okay? So this is for question 1, okay? It's a single choice question. There's some metadata here, right? This is, what do you think this is? This is the question contents. In what sort of physical activity are you currently engaged, right? What is this? Well, okay, it's the answer to, and in this case, it could have been multiple choice. In this case, though, it was a single choice. So this is the answer. And notice when it gives the answer, it gives their response sitting, right? But it also gives the ID of the response, which is associated with sort of which item they chose, the index of the item they chose, something along those lines. And then the time of that response, right? Do you see that? Yeah. So in short, there's metadata and data sort of entangled up here. What's more than that, this is a JSON structure, right? And this in particular is associated with JSON. Okay, it's actually got sort of these different sub pieces associated with it. So it's a nested structure, and it gets a little bit messy for extracting it. Okay. Okay. So what we're going to be doing is parsing these values into a structured form that we're going to be able to make use of. Okay. Rather than piecing apart these rows and trying to untangle this ourselves, we'll use a JSON parser to parse all this and extract them into nice fields. Okay. Okay. So that's the motivation for defining these case classes, and we'll be able to use these in many different contexts. So I'm going to define a case class here. Okay. Ethica survey question single response. Oops, not single, single. Response time is going to be a string. The answer content is going to be a string. And the answer ID is going to be a long. Okay. So I know it's a little bit hard to see because of the things hidden behind this thing there, but I'll bring it down. So you may remember case classes are classes that provide a lot of functionality in a very simple to access way, familiar functionality associated with typically immutable constructs for these classes. And one of the things that they provide is the ability to destructure a class into its pieces. So we'll be able to build up a single response thing from these pieces, and we'll be able to take apart into these. Okay, we're using a val construct, using in a loop or in a match expression. We'll be able to take it apart into these. Okay. Okay, here we go. So that's the survey response, and then so that's Ethica survey question survey single response. So that's for single responses, and now we're going to do case class Ethica survey response. It's going to have something called Q content here. Okay. Q underbar content is going to be a string. Resp is going to be an array. Oops, array. And a key question is, what is it going to be an array of? This resp, you notice the name of these things? Not surprisingly, maps directly. Look at this. Ladies and gentlemen, resp time, resp time. Do you see that? Answer content, answer content. Answer ID, answer ID. This is not a coincidence. For the survey response, we're going to have Q content here. We're going to have resp. What is in resp? Based on my just pointing out the isomorphism between things, yeah, the resp is going to be of this thing, of the survey response. Okay, do you see that? Okay, now I know the tyranny. The tyranny of the tyranny of the screen is engaged in unpleasant responses here. Okay, so here we go. And I'm going to have one more thing beyond this, which two more things, in fact. Q type, Q underbar type, which is a string. and version, which is a string. Version. Okay. I guess version is not. I'm sorry.
Why version?
Yes, it's a good question.
Order
Order
ID,
ID.
right?
The Ethica survey response, Q type, and yeah, I would expect order ID. That's true.
Already filtered by version.
Yeah. Okay. Let's do order ID. I wonder if the definition changed some here. Okay, let's try long here. Okay. We have to be a bit careful because I don't want to throw this off too much. Okay. Okay, so let's define this guy. Okay, order ID. So where did those names come from? These names of like Q content and all that sort of stuff. It's the names of these various things, right? Yeah, Q type, etc. So we're trying to maintain a correspondence between them. Okay. I did long because answer ID was long here, or was also long here. Okay, great. You'll notice I also left resp time as a string, and that's because for some reason the parser has trouble parsing this particular string type into a defined string, and so it exhibits problems. And so I just said, okay, let's just leave it because we don't need it right now. I'm leaving it as a string, but we could probably put that into place later. Okay. Okay. So now we are able to have these case classes, which are useful for parsing this information. What we're going to do now with these case classes, which will allow us to structure it, we're going to put into place a few UDFs, which are again of general use to actually perform the extraction, okay? To parse a JSON field and extract the response text or extract the response ID, all that, and or extract all items listed as a comma-separated list, okay? So I'm going to ask for your accommodation as we define a single UDF here. It's going to be called parse single answer JSON response content. Be a UDF. This is going to allow us to get the response string. Okay. Now this is a UDF. This is going to be a UDF. Okay. So what are we going to apply it to? What are we going to apply this to? We're going to apply it, ladies and gentlemen, to a column. We're going to apply it to a whole column of answers, and we'll get back the response from that, okay? So we're going to be able to take a column of these guys that consists of these guys, these responses, right, that we extracted here, resps, and we're going to be able to extract for question, say, 3, give me, applied to that column, we're going to say, give me for question 3 the answer, as strings. And we can then add a column of that, of those answers to question 3 on these survey responses. And that will allow us to then manipulate those answers, okay? Not as part of JSON, but as strings. So it'll say sitting, standing, lying down, walking, or something like that for these different rows. And we'll be able to then group them by like sitting, or group them by or you know, group them sitting, standing, and have a count, or we'll break them into a pie chart and we'll show the count of each in the pie chart. Does that make sense? Okay, so that's where we're going. And we're going to have another UDF, which is going to extract the ID number of the response, like it's response 2 or response 5. And that would allow us to manipulate that further. But let's get this first UDF in place, okay? That's where we're going with this UDF. Okay, great. So what's going to be in this UDF? Well, what's it going to take in? What's it going to take in? Well, it's going to take in, it turns out, the response, the resps, are going to be treated as a string here, okay? So it's going to take in a string, and yeah, and okay, so it's going to be str, it's a string. So maybe I'll just say Ethica question response, okay? It's going to be a string. And again, because of the tyranny of this, I'll try to sort of put this down. Maybe I'll put it. Come on. Parse. This is not. I keep on saying stringle. Okay, there we go. There we go. Okay, this is going to be. Remember, UDFs take in functions, right? The functions operate on the particular values that are in these columns. And so we're going to have a UDF, and it's going to be, the function here is going to do some slightly complex things, okay? But it's not going to be too bad if we write it out systematically. Okay, so first of all, I'm going to say implicit val formats equal default formats. Okay, there we go. We're going to tell it to use default formats. And then we are going to parse, and this is the JSON parser, the response, okay? We're going to parse this string as JSON. And then we're going to extract the string is the whole row, or the whole response. It's part of this row. It's going to be a whole response, and we're going to extract from that. Extract, and this is going to be an Ethica survey response. Okay, Ethica survey response. Okay. And we're going to take response, okay, response here, 0, and answer content. This is a single answer thing, so it's just going to be an item 0 here. There we go. Hey, come on. Hey, oh man. It sort of put it right at the wrong. Okay, there we go. That's a little bit better. We'll do it this way. There we go. Boom. And there. How's that? Okay. So the Ethica question response, we're going to be parsing, and this is going to allow us to kind of extract a response to from this, and we're going to then put into place a capacity to extract for a particular question number, to extract the item for a particular question number, which is going to then get parsed further. So I'm going to say here, this item for parsing this. So this is the parse single answer JSON content UDF. Okay. Okay. Next, we are going to, and I'm looking because I'm wondering if I have missed an item here in my definitions, because there's a response generator that I have that I don't see referred to here. Okay, so this is our UDF, and this the job of this is going to be to parse the responses in X, which will allow us to then extract the question number. Okay. If you could pardon me for just a moment, I think I'm missing a component here that we're going to have to define in order to apply this. And I just want to go get that. Okay, so give me a second here, and we're going to need to go find this. Here we go. Okay, and okay, okay, so this is winter and code fragments and sandbox. Okay, great. And we're going to look for, we're missing key component that's going to take this up one level and in terms of abstraction. Okay, so there it is. There it is. Okay. Okay. And there it is. Okay. Okay. Right. Okay. Good. Good. Okay, ladies and gentlemen, I'm sorry for the distraction here, but we needed one more piece which wasn't in here. It's this guy here. Okay, let me put him down slightly. Oh man. Okay, there we go. Okay. So this construct makes key use of closures. Okay. This is not this is a UDF generator. It generates user-defined functions. Okay. So what does this do? Well, if we give this thing a question number, it will give us back a UDF, which will then extract that question number from a column, right? A UDF's job in life is to process a column. And if we use this function and we say, I want to create a UDF to extract question 1, it will give us back a UDF whose job in life is to extract question 1 from the survey data. Okay. By contrast, if we give it question 3, it will give us back a UDF to extract question 3 from the survey data. Okay. And that's the sort of flexibility we're going to need. Okay. What is this M? Well, it's a map. It's a map from int to strings. Where have we seen a map from int to strings before? Can anyone tell me? Where did we see a map from int to strings? Yeah, these responses were a map from int to string. And that is what we're going to be applying them to, these responses. Do you see that? It's the responses to the survey. And we're going to be able to use this UDF to extract from this map the response to question 1 or the response to question 3. And we're then going to be able to further parse that, okay, in terms of the answer text or the answer number. So I know this seems a bit confusing now, but let's apply it and we'll see how this works, okay? Okay. Here we go. Val joined survey Excel var actually responded to, okay, delete this actually responded to. You don't need that. We already have filtered by that. Joined survey. Oh, okay. No, joined. It won't be actually joined. Sorry. We will say DF. Survey question with question info. Okay. And we are going to operate on the DF here that we were using earlier. This guy here, PA sampling survey responses. We're going to operate on him. This is the one we were manipulating earlier. Do you remember this? We did collect on it. Remember that? It's just information from the surveys. Okay. Survey responses. This is our normal sort of survey response data that we had extracted. Remember, like this stuff? Okay. Here's our survey response data. And we are going to say, do the following. We'll say dot with column. Okay, with column here. I'm putting these in separate lines so we don't run into that and so on. Dot with column. And we're going to have question 1 info. And guess what we're going to have for question 1 info? It'll be this stuff here. It'll be whatever's extracted from that map. This guy, it's going to be this string. And then we're going to go and parse that string with this other UDF we just defined, this guy here. That string, and it's going to extract the answer content, sitting, standing, or whatever. So here we go. We're going to have in that column, we're going to extract information on question 1. And the column, so what is this going to give back? If I call that, what is this going to give back? It's going to give back a what? A UDF. Yeah, it's going to give back a UDF, ladies and gentlemen. And so a UDF, its job in life is to be applied to what? To, it is a function, but it's a function applied to columns. So we're going to apply this to guess what columns. Guess what column we're going to give it to. Its job in life is to extract the first question information. What column would we apply it to here? Would we apply it to duration, to user ID, to survey ID, or to resps? Resps, ladies and gentlemen. We apply it. Okay? Are we okay with that? Okay. Okay. Hearing no objections. There we are. Okay, let's go check what this looks like. Okay, you ready? Glad everyone is ready. Okay. Here we go. Let's just see if we could show it, right? To get a rough idea of what it looks like. Okay. So there's question 1 info. Well, it's all messy. It's mixed with other things. So let's just do select Q1 info. You ready? Okay. There it is. This is question 1 info. Okay. Are we okay with that? Okay. Well, I'm glad no one's. Yeah. Okay. So no one's objected. Okay, so next, what are we going to do? We're going to extract from it using, yeah, this parse, it says, still says stingle. Okay, on mine, don't make yours stingle, okay? Ladies and gentlemen, take it from an old man. It's better to be single than stingle. Okay. Okay. So, here we go. There we go. And we are going to parse. Okay, we're going to parse it into. We're going to do. Oh, sorry. What I wanted to actually do was to show this guy with question info. So we don't need this one. We're going to do dot with column. And we're going to create a new column, which is going to be Q1 question response. Okay, Q1 Q1 answer text, we'll call it answer text. Okay, and the answer text is going to be the result of parsing Q1 info that we just extracted. Okay. Now I'm gonna put this down below just so we can see where this came from here. Here we go. Hey, there we go. Ah, yeah. There we go. Okay. Okay, and so this is going to be val EF survey here with Q1 answers. Okay. We can do this more efficiently, but I just want to walk you through the process here. Oops. Okay. Okay. Found string. Okay. So sorry, I need to focus in on this. Okay. So type mismatch. It's requiring a column for the UDF. Oh, I see. Okay. Oh, yes, $sign. I'm missing a $sign. Okay. There we go. Okay. You see that? Okay. Now let's just go look at what this Q1 answer text looks like. Okay. Select Q1 answer text, and let's show it, or let's collect it. Right? Let's collect it into a collection. There it is. What do we see? What do we see? These are the responses, right? Let's go look at, because it's got some extra brackets around it. Let's go look at print schema for this. Print schema. Okay. Boom. Now we have a Q1 info and we have a Q1 answer text. Okay. Where the answer text is this is sort of the responses here. Okay, so what we're going to do now is we will actually put this in a little pie chart like we did last time. Okay, so here we go. Q1 answers, and we're going to do create or replace temp view, and we'll create one called survey responses, survey answer responses. Okay, so it's going to be It's going to have the kind of the answers in it. And now having done that, what can we do? We can go into Spark Cassandra.sql, right? And we can do select. We can select Q1 answer text. Select Q1 answer text and the count of Q1 answer text from what? Survey answer responses, or grouped by what? Q1 answer text, right? There we are. And now what can we do in a triumph? Yeah, we could do pie chart. Okay. Yeah, sorry. How far up? This was just to have us look at it, but I did create or replace temp view. And this is with that same thing to which we added this guy here. Okay. Would it be helpful for me to sort of just retrace our steps how we got here?
I just need the last line before the charts.
Oh, okay.
Yeah.
The SQL.
Yeah.
Got it. Yeah. Look at that pie chart. So how did we get here? Well, we went through basically two steps. I mean, we defined some UDFs, but those are things you can routinely reuse. So that's not really the heart of it. The heart of it is we use the UDFs to extract from RESPs, from the survey responses in general. So each response to a survey in Ethica has many questions in it, right? I respond to a survey, it has questions for this, that, this other thing, question 1, question 2, question 5, question 4, you know, whatever it is, right? That is many questions. And those questions are mapped, and those questions, there's a map from question number to the actual, does anyone need to see this longer, or can I go up? Is that okay? Okay. So ladies and gentlemen, just to sort of recap this, if we go way up here, right? Here, when people responded to a survey, there's a map from the question number to a string that tells what did they answer for that question number. You see that? Okay, this is a map. Now, what made the situation more challenging is that if we actually looked at this map here, what we actually found was that it could be represented in Scala like this, but it was mapping to a structured quantity that's actually a JSON object. Okay, it's got sort of keys and values. Do you see that? So yes, it's a map, but it's a map from question number to a bunch of info about the question, okay? And this is actually a JSON object. I know it shows it as sort of separate things here, but it's actually a JSON object, okay? So this thing of this curly bracket is a JSON object. So we needed to parse that into pieces, okay? We need to parse it into pieces. And long story short, we defined some case classes and then some UDFs, which would allow us to take this apart. It would allow it to take it apart into two key things. One is a structure for this entire thing, which recorded things like the order number, the question type, the question content, etc. That gives us that information about the question. And then the second type of case class was for the response to the question, okay? And associated with those case classes, we defined some UDFs to extract them. Now, a key thing that we defined is something whose job in life is to extract from a given response to the whole survey, like this whole thing, a given response to the whole survey. Excuse me, it's I guess this guy here, but in many surveys it would consist of 20 questions or something. We created this UDF generator for a question number. So its job in life is you give it a question 1, and it will give you back a UDF whose job in life is to extract question 1. Or you give it question 20, and its job in life is to extract question 20, okay? And using that generator, we added in a column called Q1 info that's basically consists of a string that is a JSON string, which is all of this here, this stuff here, okay? So it extracted the associated JSON string for that, okay? And that was this Q1 info thing. And if we looked at Q1 info, we saw here this is JSON string. Do you see that? This is actually a string. I know it's confusing because it has quotes around it, but there's quotes within it to make it especially horrible to deal with manually. So this is a JSON string that we extracted. What was that string? It was the response in the survey to question 1. Why question 1? Because we told it to extract question 1 here. We could have told it to extract question 20. And if there was a question 20, it would extract it, okay? So we added a Q1 info, which was the result of applying that to the response. Now, given that JSON string that we extracted for Q1, what did we do then? Well, we extracted a single answer from it. We knew it was a single answer question. So we extracted the text for the single answer, what the user returned back, which in this case was sitting, 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 standing still. So a given survey, remember we had put in Q1 info, the JSON object, the JSON string for question 1 response about question 1, which includes the question itself, information about what sort of question type it is, and so on. And then this guy, this guy here, basically parsed that Q1 info and extracted the particular text that the user responded to in the single answer question. And that's what this is. And then we created a table, a temporary table, and we graphed it out here. Do you see that? And this is the count of the different survey responses. Do you see that? Yeah. Now, what we took into place, what we put into place, has had many pieces to it. I mean, we had to type case classes, right? We had to go and define these case classes. We had to further define these UDFs. We had to further define this UDF generator thing, this UDF generator. But the good news is every single bit of that can be reused for any survey processing, well, for survey processing tasks. We don't have to retype it every time. That's a one-time investment. There is, however, an additional little bits that are useful. For example, I have corresponding ones for multiple entry questions. By multiple entry, I mean where you don't just select I'm sitting or I'm standing or I'm lying down. Instead, it might be, you know, I have several possible answers. So what's my motivation for going and exercising? Well, it's partly recreational. I want to be outside. Partly I want to accompany a friend. Partly it's for health. and I have all three of those answers. And it turns out that Ethica has those packed up in survey response JSON in a slightly different way, and I have code to extract that. But I realized it was a fair bit. But really, all you have to use from now on is you have to do this last little bit of stuff. And in fact, if we were to try this, in a more reproducible way, what I'd probably do is the following, just to sort of ease it. So I'd probably do all of these in a single. So this extract survey responses, this with column, I would put it right after where we added the column Q1 info, which is, Q1 info is there. I put this just before this guy here. And in fact, you might be able to nest them. So you just say, parse this on the UDF, the result of doing this guy here. Hey, let's go see if we can do that. Can we do that? Are you okay with that? Okay, thanks for your permission. Let's go do it. Okay, that would be cool. Okay, let's just go see. Okay, watch this. We'll end this class in a blaze of glory, hopefully a good one. Okay, but even if we fail forward. Okay, so here we go. Let us go and do the following. Watch this. Q1 answer try to, okay, or sort of easy, okay, easy extraction. Okay, so what we're going to try to do is do the following. We're going to apply this like this. I don't know that this will work, but let's try it. So no, okay, resp cannot mumble. Is it resp? Okay, I could. Sorry, should be resps. Should be. Okay, I have down here resp, but I think it may be resps. Resps. So how did that come in? How did that not get caught? Maybe I deleted it later or something. Okay. I'm just re-executing these things. Yeah, it seems to be resps. Okay. Okay. So this is resps. Okay. And now let's do this. Dot print schema. And there. Q1 answer easy. And now let's do this thing. Dot select Q1 answer easy. Dot show. Right? Here we go. There we go. Look at that. Look at that. Somehow you folks don't seem to be swooning over its greatness, but it's it's great. So what we were able to do is we were able to avoid just adding multiple columns in and stuff like that. We were able to instead just say, okay, look, add in a column if you even want to add in a column, for this, and this is our UDF to process the answer. And it gets the response of this UDF for a particular question that parses this and extracts a particular question, right? And so here we get back for answer easy, the response is the single answer to question 1, right? and we were able to summarize it, and we could put it into a nice, a nice chart if we wanted to, right? So we could go up here and put it into a we could put it into something like this, and boom. And then we could plot it out in the same sort of way and get probably the same in general sort of results. Okay. Oh, and then here's our pie chart, or alternatively, if we want to do it as a bar chart for the different possibilities, there we go. Okay. Extraction, ladies and gentlemen, of survey results. Big picture, we added a library to allow us to manipulate JSON. The JSON library allows us to parse complex structures as encoded with strings and turn them into elements of case classes. With those elements of case classes, we could then structure that information in a way that would allow us to extract particular things from it. We defined these UDFs, which allowed it to the particular items to be extracted. And by so doing, we were able to bring out subpieces. In this case, it's the particulars of their responses to those questions. Okay. Alternatively, if you wanted to extract not their answers, but you wanted to extract the response number, all we'd have to do is to define one of these guys here to okay, this is to extract this is to extract that. So we'd have to define a UDF here to return, instead of answer content, we would return answer number, which is another alternative. So here we go. Answer content. It's called answer ID. So if we wanted to return the kind of what answer number they gave rather than the text of the response, we could just do the following. We could do, instead of saying response here, it would be answer response ID. And instead of saying answer content, all we would say is answer ID here. And then we could simply, when we're parsing this, we could do with question, we would have done something like this for question response ID, like that. Okay. And that would give us, with question response ID info. So all I did is I defined this UDF, same as above, as the above one. This is the UDF to extract from question JSON to extract the, from JSON string to extract the ID of the answer rather than the answer itself. And so I just named it slightly differently. It's response ID and called it answer ID. And then here I can run it and we'll get this. And then there would be a, answer easy ID, answer ID, I'll call it. Yeah. And I could extract now from here, dot select Q1 answer ID dot show, and this would be all the different answer IDs that they gave. Okay, so that specifies not the text of the answer, but the ID of the answer. And all we had to define there was a different UDF to extract that from the JSON string. JSON string being parsed, extracted as a survey response, extracting element 1 and getting the answer. Okay, that's all we have time for today. Extraction of Ethica survey data. Okay, I will share this code with others, and I will share an exercise. Okay, thanks very much.